Good evening, everyone. Welcome back from, hopefully what was a wonderful summer for you. At worst, I hope it was just pretty aight, as I mentioned to the Dev Edmonton Slack. Welcome to our September edition of EdmontonPy. Let me get our slides started here. Perfect. So, I guess I should have introduced myself before going straight into the slides. Hey, my name is Aaron. I've been organizing EdmontonPy for probably 2.5 years now, maybe? I don't know. Started losing count. But yeah, I will now go straight into the slides. Alrighty. So even though we are meeting virtually, most of us either from Edmonton or Calgary, hopefully from other places as well. I do want to thank Startup Edmonton because they did purchase a subscription for Remo, so that a lot of our meetups that used to meet up in person are able to use Remo, which, in my opinion, nothing's going to replace the in-person experience, but I've actually enjoyed using Remo a lot. So thanks again to Startup for purchasing a subscription for Remo. And I feel like this is just that bog standard. Personally, can't believe we're still in this, but we are. So here are some links to make sure everyone is up to date on what the heck is going on. In terms of jobs, we do have two, I guess, local to Alberta, local to Edmonton job postings. One from Levin Technologies. They are looking for a senior software developer, someone with any like embedded systems or IoT knowledge. They are really looking for that. There's also a financial trading startup. They're so startup-y that I don't think they have a name yet. They are looking for someone who's part-time with Python experience. They are namely looking for someone who's used Decorator's web and worked with WebSockets and APIs. I will send or paste the link to the slides here after I'm done going through them. There will be links that can take you to the requisite ways to apply as well. There are also lots of remote positions. These links, again, take you to these different websites. And then the third place to kind of look for opportunities or to even advertise your opportunities would be that opportunities channel on our devedmonton.slack.com Slack workspace. In terms of events, I have seen that PyCon is still happening. Not sure if any of those are happening in person, but they are still happening on a regional, setup because they have different geographical organizing groups. But PyCon has a couple conventions staggered. First one in Taiwan in October, then South Africa, and then Sweden. So I looked at the schedules for all three. There are very different talks across each of the PyCons. So it just goes to show how ubiquitous Python is becoming. I'm sure that there's tons that you can learn from any of those PyCons. And as well, if you wanted to kind of dive a bit more specifically into the data science part, well, one of the largest ones, PyData Global, is happening virtually from October 28th to 30th. So again, I will find the link. Apologies, Rusty Organizer here didn't paste the link, but I will get the link after I've finished presenting these slides. I did find these events from the official Python events website, so feel free to check that out from time to time as well. In terms of news and articles, Python 3's release schedule has actually been quite quick. I don't see that as a bad thing, really. I see that RC2 for 3.10 is available, which means that 3.10 will be available, the stable release in October. What's really exciting about 3.10 is that union types can just use that, what's that vertical, like line symbol character instead of having to type a union function x comma y. So that seems pretty exciting. As well, they will add support for type aliases. So if you like your type hinting in Python, but you didn't like the fact that type aliases felt like a bit of a hack, well, in 3.10, you can define your type aliases and make them explicit. So, your tooling and your linting, it's all going to have support for your type aliases. And then last but definitely not least, in 3.10, I think people have been asking for like a switch case style way to write your code. Well, switch case is happening, but in Python style, and they're calling it the structural pattern matching. So pretty exciting to see that lots of community feedback is being incorporated into 3.10. That's RC2 is ready, but the stable version's showing up next month. As well, if you haven't heard of PyPy, it's an alternative to what's called CPython, otherwise known as just the Python that if you install and don't know which implementation of the Python runtime you're running, you're probably using CPython. But PyPy uses a just-in-time compiler, and in some programs it makes it a little quicker. And this one's a bit more of an advanced article, but it does talk about their journey in increasing their support for auto-generated Python code. So it actually didn't even occur to me that, code generation does happen and quite a bit within the Python ecosystem, most specifically in like rendering of web templates, for example, on the server side. So their article goes into specifically Tornado's template rendering engine and how it was having lots of performance issues if that code was run on PyPy. And it goes into kind of beginning, middle, and end of that journey. I thought that was a pretty interesting one, so please take a look. And I wanted to add in the Real Python podcast episode 77 because its theme of advantages of completing small Python projects is a great tie-in with our presentation tonight. So a little bit of foreshadowing there, but in case you needed even more impetus to start your own small projects, well, feel free and listen to Real Python episode 77. And I wanted to kind of conclude the articles with something a little bit fun. I noticed when I looked at some of the older slides that back in March, we were talking about Python in space. So I decided to continue down that line and found that Microsoft has this basically 2.5 hour self-guided tutorial that teaches beginners Python, but kind of teaches them in kind of a more fun context and goes into where Python is being used within NASA for space exploration. So you get to learn about Python, learn how to use Python with Jupyter notebooks, and you get to see where Python's currently being used in space. So I consider that like a 3-in-1. I think that's excellent. Python tip of the month. Do apologize because I think this might actually be a tip we've used before, but remove prefix and remove suffix are now standard string functions starting in Python 3.9. And I really like the way that the function just kind of describes what it's supposed to do. I think that's very Pythonic. Wanted to include just a little very specific note on kind of what is the difference between something like remove prefix versus a left strip function. So for those that don't know, left strip, the argument that you pass as a string is actually interpreted as a set of characters, and that character set is recursively applied to the string. And so effectively what you're seeing is Arthur 3, and if any of these individual characters is seen, and that includes the white space, is seen as in your left-hand side starting of your string, it will remove all of them. And that's why when you execute this line in your Python REPL, you'll get EE exclamation mark, which if you use lstrip for the first time and you thought it was removing a prefix, well, you, if you are on Python 3.9 or newer, can now use remove prefix instead, and that will get you what you probably expected. Of course, that doesn't mean that lstrip is no longer got any use cases, but it now that remove prefix and remove suffix are available, it's just more self-documenting. And if you actually, again, once I share the slides, if you look at the PEP 616, you'll actually see examples of where usages of lstrip can now use remove prefix instead, and it just leads to slightly cleaner code. Okay, I have rambled enough, but tonight's talk is by Daniel Zhou, and it is called Information Retrieval, a simple search service. And just before I get Daniel up on stage here, I just want to let everyone know that if you do have questions, to feel free and pop them in that general chat. Or if you really want to get my attention, you can use that Q&A tab as well. But I found that it's fine if you just use the chat. Essentially, message away, but I will allow, I'll let Daniel make sure that he can present his presentation, and then we will get the Q&A, we'll get him to provide his answers at the end of his presentation. Where do we get the information contained on these opening slides? So, great question, Christopher. I will find the link to my slides, and I need to find this without causing the whole screen to go crazy, which it probably is anyways, but I will paste the link shortly. Okay, so without any further ado, I will let Daniel take the presentation away.
Okay, cool. Hey guys, is the sound and everything all right? Kind of cut out for me when I switched over, but it should be
You
fine.
are good.
Yeah, nice, perfect. Yeah, so hey, my name is Daniel Zhou, and as Aaron said, I'm here to present to you about information retrieval with a simple search service. So let's drag this out of the way for the time being. And yeah, and get into it. So a little bit about my story. I'm a new grad from the University of Alberta. I'm currently working as a full stack developer at Intuit, and I took Compute 361, which is the Intro to Information Retrieval course at the U of A. So why this project? Well, I thought information retrieval was pretty neat. Search is a pretty useful feature, and search is a pretty good subject to get into working around with some of these online hosting services for setting up a search workflow. But the main contents of my demo today would be a focus on two information retrieval methods that I hope may be relevant to you in the future, and some brief thoughts on doing side projects and a little bit of a retrospective in that regard. So yeah, so my project is a simple toy search service on movie summaries. For that course, I got a toy data set of approximately 1,700 movie reviews slash summaries as just as a demo for text retrieval methods. And that being said, I was playing around with hosting two complementary search interfaces for this particular data set. So without further ado, I figured we'd jump into a demo of it here, and I'll post a link in the chat here for people who might want to play around with this with me. So yeah, so we called it Flask IR movie plots. Kind of says exactly what it is about, and really the main contents here is an API for Boolean, what is called Boolean information retrieval, and another one for vector space information retrieval. There's a nice convenient little form here that we'll run through to play around with this a little bit. But before that, let's take a look at this data set. So in summary, this is really just a big array of JSON documents. They contain a doc ID, they contain well, they title it a review here, but if you actually read the contents, they're more or less plot summaries, and they have a title. The main thing I wanted to kind of convey with this is that this is text content. It's delineated into varying fields, and that'll be important shortly here once we jump into the actual IR methods. So yeah, just gonna have some water. Yeah. So I wanted to talk about Boolean information retrieval and vector space information retrieval, because these are two good complementary search methods in that they have complementary views on this notion of searching and getting information for a particular query or informational need. And starting off with Boolean information retrieval, as developers, we kind of have a good intuition of what this is really about. We're simply kind of trying to formulate our queries into some sort of Boolean expression that then documents would satisfy. So in my system here, this is actually a zoned Boolean retrieval system, in the sense that for a given query, such as this, we can actually specify the exact zones of the document for the said information. So in this case, I would be looking for documents whose reviews contain the word airplane and the word the. As an example. So we can request the actual documents and run this, and this will generate us a count of 21 documents from the document sets before, containing the word airport, for instance. So yeah, so this is kind of neat. This presents a little search interface that you can query and do things on for these documents. Some neat considerations for this type of system is that typically but before that, one thing that I wanted to share with this was that this can typically support just any like query you can think of for this on this data set. It's kind of neat in that yeah, these queries can be quite complex, and this thing will run them, parse them, and spit you out relevant documents and such. But moving into some tidbits about this type form of search. For one, we don't usually think about search as a system where you can say get all documents not containing a word as well. So this is perfectly valid query, and we can fire this off, and this will ping the appropriate indices to do so. And as it turns out, this entire data set actually contains 3 documents whose plot synopses, reviews, don't actually use the word the at all, which is actually kind of surprising in some senses, especially this one being actually decently long. What is this? Johnson Family Vacation. So yeah, so that's kind of neat. So let's think about Boolean searches in retrospect for a second here. So these seem pretty powerful. They seem pretty transparent in their action, but this model can be a bit tricky in 2 senses. For one, you kind of need to have a good idea in terms of what you are looking for, and if you don't, it leads to a feast or famine situation where your results might be too precise. Can't think of one right now to run with that, or your review or your query might be too general, such as if I just query the dataset with the review the, and this will give me effectively the entire document set back. Another thing is that even if we find documents that satisfy our information need in this case, we don't really know which one is the best out of the bunch. We could perhaps we genuinely are looking for movie plots with containing just the word the. In that case, well, presumably we're looking for ones that use the word the most, or something such like that. So that moves us into vector space information retrieval. And the 2 benefits here of note are, firstly, we we're starting to move away from this idea of having a more rigid syntax to search. Dropping the Boolean restraint, we can just use these phrase or keyword freeform searches that we're more accustomed to. And it also supports scored retrieval. It'll give you some notion of relevancy with respect for a given document with respect to your query. So you are able to sort and rank things by relevancy. So on my implementation here of vector space information retrieval, I actually also have this notion of phrase of phrase queries as well. So instead of this just being an array of keywords to work through, for instance, in this query, go to the is a phrase. We're looking for documents that contain those 3 keywords in a sequence here, in addition to the term moon. So we can hit this off and get a set of documents here. 5 documents because we requested 5 in some notion of a order of relevancy, starting with evidently document 30 being the document that presumably uses both the phrase here and the and the keyword moon. So yeah, so this is kind of neat. This provides us with a overarching interface for just kind of running these searches. So I think what was the phrase? Go to the moon. So that is one. Why is this not ping? You can actually see the phrase right here. There is a bunch of those, but oh well. That's, I guess, one thing that doesn't go right in the presentation. So yeah, so this is kind of neat. One thing on top of this is actually this idea of relaxing queries when the collection of documents and such don't or aren't able to meet the query completely. So in this case, one thing that we can do with this is that if we bump up the K for the number of documents requested here, this search query is actually broken down into successively smaller phrases, provided that it can't satisfy this K number, this number of requested documents fully. So in that sense, here, one thing to note is that if we close the relevant docs, we start to get a different ordering of relevant IDs, and this is because of that query expansion happening in the background. So in this case, presumably what has happened is that this phrase, go to the, is too specific, and instead of trying to meet that phrase requirement directly, this search engine where the search service will actually break this successfully down into the phrase go to and to the, and then if it can't match 50 queries or 50 documents to that, it'll actually just decompose this phrase entirely into its keywords and then run a batch search on that instead. So yeah, so this is kind of neat. We have 2 different search methods that work on that have 2 different querying structures and that provide different benefits and costs and such. Yeah, that is kind of cool. So going into a little bit about why should we be excited about search and how all of this stuff works. Let's just try to recap on why is search useful, why is it kind of exciting, and yeah, go from there. Just having some water here. So yeah, so search in this context is, or rather in the IR context that I presented here, is more specifically focused on text retrieval. And in general here, what we're doing is that we're trying to find material that satisfies an informational need expressed as a query. And well, why use this? Why do this at all? It's a convenient feature to use. It's easy to use. It's direct if you know what you're looking for. And most search engines like Google will provide you autocorrect and recommended things, so they're fairly tolerant of user error or ambiguity in that sense. So that leads us to say, like, why implement it? Well, for one, people seem to like it. People seem to like it a lot. In the context of perhaps some more data sciencey AI/ML type of stuff, when we talk about recommendation systems, well, information retrieval and relevancy systems can be a strong contender in that area because they can be simpler to make. They can be a bit more transparent in their action, and in that sense, they can be a little bit cheaper from that view as well. So yeah, so getting into the implementation details a little bit here, just to recap: Boolean retrieval, express queries as Boolean expressions, find the documents that satisfy them. In vector space information retrieval, we're treating documents and queries as vectors inside this keyword space, and we're trying to find some notion of being able to score and rank the documents by similarity in that space. Um, so yeah, going to Boolean retrieval, what I do here to implement this is that I take a search expression tree, and I can recursively compute the resultant set of documents by treating the operators as set operations and parsing these symbols as getter calls to an index to actually retrieve the documents. And well, how do we kind of get at this search expression tree? That's kind of the crux of this. And to that, I use this library called Boolean.py. So the example here is really demonstrative. It has this nice functionality of being able to parse and simplify Boolean expressions. So in their example here, as you can see, x and y becomes this binary tree, and being the root node, the symbols being the leaf nodes, and parsing perhaps more of a natural language type of flow for this. This long expression about apples or bananas and oranges and pineapples and lemons and cherries and such becomes a bit more of a complex tree, but it still follows this structure there. So yeah, yeah, I just wanted to give a higher level overview of kind of how these two things are implemented inside my simple service here. And moving from that, we can go towards vector space retrieval. So in this format, two key steps here is really just being able to plot documents and queries, which are just short documents inside this keyword space, and then being able to compute this notion of similarity between documents. So I'm going to work through this through first looking at actually plotting the documents, and then talking a little bit more about the similarity at the end. And let's just, or rather before that, let's consider this image here as a pretty intuitive example. We're plotting two documents and a query inside this two-dimensional space, so against two keywords. And yeah, so we're looking to determine some notion of similarity. And going from there, we'll see that angle similarity is kind of a very useful measure of how relevant two things are. So imagine if this query was more leaning towards document 1 or document 2, should how long these vectors how long these vectors are matter inside the calculation for how similar two things are? Well, imagine if query 1 is actually just imagine if document 1 is just the query duplicated and appended to itself. So it's essentially the same document. Well, in that case, it should be the same thing from this similarity perspective. And in that case, the query will be somewhere closer to the middle of this vector. So to actually have, it have a very small, if not any angular difference. So yeah, so this notion of like angle similarity is pretty useful when we're talking about comparing these things in abstract space and normalizing for text length to an extent. So let's talk a little bit about how do we actually plot these documents inside the space. And in that area, I want to introduce you to this idea of TF-IDF scoring. And this is essentially a family of different things that play along the same theme to generate a single number to associate a given dimension here. to a particular document. So let's just consider what would we like for a given axis, a given dimension, and there's two parts here. So term frequency, or let's actually start off with the other one. So inverse document frequency is talking a little bit about the distinguishing capability of that keyword as a whole, and then within that bound, term frequency then talks about how exactly does this particular document fit into that range. So why does that? What is this distinguishing capability? Well, if we think about two words, say the word the and apple, well, typically, as we just saw, a lot of words or a lot of documents in English typically use the word the, and it's not a very distinguishing word in any shape or sense. So that being said, the word the as an axis, as a dimension, should probably be weighted not so heavily. It's not very useful as a distinguishing term, but the word apple, though, in contrast, likely not going to see it in that many documents, and therefore it's much more distinguishing for scoring, for weighting scoring on this notion of relevancy. So once we have those that notion determined, how relevant is this dimension as a whole, then term frequency allows us to say presumably that we're a given document using that particular term more often would be more relevant to queries asking for that particular keyword or dimension. And then after that, once we were able to plot these documents, we're able to compute this notion of similarity across to finally rank and score our documents. So yeah, moving forwards to there, there's a lot of considerations with text, with setting up the search service that I've kind of skipped, but just kind of mentioned them briefly. Index creation and text parsing is, of course, a big consideration when trying to catalog all of your documents and such. In terms of the Boolean search functionality I've implemented here, one of the things I do is that I actually maintain a sorted order for my indices, and because of that, I can do some optimizations regarding fast comparisons there. So I actually wrote my own comparators for those instead of just relying on, like, say, the set operations provided by Python. There's a fair amount to say about, like, vector space scoring in terms of how do you weight terms and how do you normalize for document lengths and the such. And there's a fair amount of play there for both performance and for both accuracy in terms of accuracy towards the to a given query and the such. And and lastly, this idea of taking phrase queries via a positional index and a method of query expansion, in my case, query reduction, being able to break down search terms which are a little bit unfeasible or not within the scope of the collection to more things that might be potentially relevant to the informational need of your user. So that is that. Quick overview of the implementation. There's a package called NLTK. It is great for natural language processing and text parsing needs, and I use that essentially as the basis to parse the documents, tokenize them into individual keywords and such, and to generate the index. As we saw, Boolean.py is a powerful thing to parse Boolean expressions into these Boolean syntax trees, and lastly, this little demo site is hosted with Flask and Heroku. So just a quick recap. Search is a pretty useful, interesting feature to implement, to work around. Boolean search systems, they can be pretty good for power users because they're fairly direct and fairly transparent form of search. Vector space search methods, though, or search systems, can be pretty good as a generic search type of implementation. And Python specifics, Boolean Py and LTK once again. So just leaving off on a couple of soft takeaways. I found Compute 361 to be a pretty neat course. That's Introduction to Information Retrieval. It is September. If this was earlier, I'd encourage people at the university to take a look at the course and to maybe enroll in it. But whatever. Yeah, and working on this project in summer, just a quick 2-point retrospective on a couple of things that I found to work pretty well. Early in the year, I was I was looking into how do you kind of manage time better, how do you kind of get the quality productivity time required for that. And one thing that I found to be really helpful was time boxing time and managing like these little projects via this thing called GitHub projects. So, you may work with some sort of Jira board or something of the such for your day job and the such like that. And I found that GitHub actually provides you these for free in the projects tab, and I thought it was just a really useful way to have a self-documenting little bit of things to track how your project is going and how you're logging the things that you're doing with this and things that you plan to do in this in your side project. In that, yeah, it's just a great way to keep organized through longer periods of time for that. Yeah, so that kind of concludes my presentation. I'll check out if people have any questions.
Yes. So I will ask you, Daniel, could you actually keep that presentation up? Just so that, yeah, it's for the video.
Oh,
But
cool.
Christopher did have a question here, so I'll just read it out. And yeah, you can respond with okay. So essentially, the question is, in what form is the data stored? And is there a database engine being used here? Or is this a flat file with Python doing all the retrieval and filtering?
That's a great question. So in my case, this service actually just operates on in a well, it operates on a couple of index files generated from that, or well, I guess from that collection, but the collection is just served as a flat file. I was taking a look at putting this up on something like MongoDB Atlas. I think that's the name of it, or something of the such. But it was just something that it's kind of future things to work and learn about. I think like definitely moving forwards with this project, like persisting the documents would be like kind of the next thing for sure.
Sweet. Okay. Yeah, if there are any other questions, feel free to post them in the chat or in the Q&A tab. I had a couple questions just kind of as I was watching the presentation and they came up. One thing I was curious about actually was if you could go back to to the demo website. I it's pretty cool because I guess when I talked to you, you said that this was still, um, you were learning a lot of these things kind of for the first time. So when it comes to, in essence, you're building an API here. So like, what was your experience like learning? How did you kind of decide on Flask? Like, where did those like how did you make those decisions? Um, just kind of curious on that side.
That is that's an interesting question. Let me think about this. Flask in particular. So some of the stuff. Let's see.
If
I
you
think I think I just have this like general log of things that I'm curious about. Like I'll
Mhm.
like write them. I'll write like some topics and stuff in like a journal or something like that. And between those two, I think like Flask and Heroku I thought were pretty good, like lightweight and easy to learn
Mhm.
tools in this area. So those were kind of the two that I went with just because of on that note. For Flask in particular, this interface for all of this, barring the actual search stuff, is like, yeah, it's 150 lines or so. So it kind of satisfied that need. Yeah.
Right, because I suppose um you're still kind of in this place where you're discovering kind of what is out there in the Python ecosystem. It's always this classic like debate between, when you start a new project and you're building an API, do you choose something like Flask, where like you probably discovered, Flask is what is considered a micro framework, so it doesn't come with all of the implementations that go into building a modern backend web application. Um, just doesn't come with those things built in. So, um, I like in your experience, did you ever find that Flask was like almost too small for you, like in terms of like, oh, it's not solving this problem. I wish it did, or just curious, like what your um, opinion after using Flask for a little bit here is compared to maybe any other libraries that you may have used for similar cases.
Yeah, sure. So, like thinking about your crew question and the last one, I've used Django in the past, and
Hmm.
I think for this one, in part, I was motivated because I didn't want to set up, like a lot of the boilerplate stuff
Yeah.
that goes into Django for this. And then to your question more directly, I didn't really find I didn't really find it limiting in any sense because firstly I came in with the perspective I wanted to learn about Flask for it, as a it is a lightweight tool
Hmm.
for your toolbox in that sense. And where was I going with that? Like over the course of like implementing this, I was taking a look at grabbing some additions to Flask. Like for one, I was taking a look at getting like a Markdown renderer to start putting
Hmm.
this page together and such. But overall, yeah, no, I didn't find it limiting in any sense really.
Cool. Yeah,
Yeah.
no, I think it's interesting that like you were able to, compare and contrast like the difference between Django and Flask, which, I didn't just want to say it out, even though I probably should have. It's pretty, I guess, common in Python these days for people to just know that Django and Flask exist. I just like to ask the question because really there's no, like, in my opinion, no right answer. It's just that yeah, I really see how within the context of this project, Flask allowed you to explore your topic while not forcing you to configure all that boilerplate that Django does come built in with, and it does save you a lot of time, but only on the types of projects where Django does fit, where you do want to use all of its features, but in this case, what I got from your presentation is I like to explore search, and maybe out of this, you're probably discovering a lot more on the web side, but at the same time, what you're also learning more about is the original topic that you went out to research, which is implementing a search, well, not search engine per se, but just exploring the whole topic of information retrieval itself. So, oh, okay. Now looks like we've got a question from Abram as well. So the question here is, as you're on Heroku, if you had to use Postgres as the database, as a backend or I assume database for this, how would you approach it, especially indexing?
Oh, gee. Um, I was actually looking into the Postgres hosting for Heroku,
Hmm.
in part because it had a free plan. I have not used Postgres, but one thing that I would be, or two things I would be interested in this space. And by this space, I mean like here the platform as a service
Hmm.
hosting and also Postgres in terms of indexing, I was thinking like as another as an addition to this. I mean, this is really just the querying portion. I think like setting up some sort of indexing pipeline and then some workers to do that would be pretty neat. But to your point in terms of like storage with that, I know that your traditional relational database management systems, they typically support like JSON as a data type, and they'll have some functionalities in terms of actually being able to manipulate that. In my case, I'm taking a look at kind of these free-form documents. The intention here is that the indexer for these documents can actually support any flat JSON object. So review and title here, they're just generic fields. So long as you have this doc ID, the thing can index it, and it'll spit you out multiple indices, one by one per field and one holistic one. On the Postgres side of things, I take a look at like kind of, I think that's a good opportunity to learn about Postgres and to take a look at kind of how does it handle like semi-structured data would be kind of a highlight for me in that area.
Yeah, and when it comes to indexing and relational databases, you're right. There's many different indexing strategies. In Abram's question, he highlighted Postgres. Well, okay, now I'm throwing in my personal opinion. I love Postgres in terms of the feature set that it offers and the fact that it's a free open source database, relational database implementation. When you were talking about JSON data types, I could be wrong here, but I have to believe that it was Postgres that sort of pioneered and forced the rest of the other relational database offerings out there to improve their handling of JSON as a data type. So, okay, I wanted to kind of keep you for longer, but I think kind of 3 questions is as much as I like to subject most of my speakers to. So once again, thank you for presenting on your small project here, and not only just talking about what you built, but also what you learned, and then kind of where you can go from here. I hope it's clear to everyone that there are infinite number of different things that you can continue to explore. And it all started with just, like you said, blocking away a bit of time so that you gave yourself that space and then could continue to experiment and discover. So what I will do is, could I ask you, it seems like the UI has changed on me. Usually it's the other host. I'd just like to ask you to stop the sharing so that I could present my last couple slides here. Thank you. And so just wanted to let everyone here know that our next meetup is once again on the fourth, have to count, 1, 2, 3, 4. Yeah, fourth Wednesday of every month. This helps to coincide both the Edmonton and the Python, and the Calgary Python meetups. That way we agreed on fourth Wednesday evenings. So that's going to be the next meetup, and we are looking for presenters. And Daniel, when he approached us, he was very open about saying, look, I've just sort of started, and what we do encourage beginners, because I think, especially for someone like myself, working in this industry, I graduated in 2014 from the U of A, so it hasn't been that long, but I got to be honest, sometimes I love to just see like the beginner's mind and have the speakers explain from their perspective like how they learn things. It's just, it doesn't sound like a long time, but I'll be completely honest, I've almost forgotten what it feels like to not know what library or even how to search, or how to just how to get started on my project even. So if you did have a talk, or even just an idea on a talk, and you wanted to see if it would work, feel free to message either myself at aaron.yong or Abram at Abram, or our other organizer, Andrew. His Slack is at dataget. Or visit us on the Dev Edmonton Slack. We've got our meetup. We've got the meetup channel there as well. Okay, so it was a September, the first meetup to kind of start off of summer break. This one's a little bit, I guess, on the shorter side. Oh yes, of course. Thank you, Abram. Being someone who is from the EdmontonPy side, I have to apologize for the Calgarians who are either in the audience or are watching this video. I don't mean to exclude you on purpose. If you are from the Calgary Python meetup, feel free to message Carson as well. Carson. So the question is, on what medium do we send these messages? We like to use Slack. So right, that's the thing I needed to end this night on. It is on Slack, and the links that are clickable, I shall repost like so. And I believe on that note, I'd like to wish everyone here, good night if they are in the Alberta time zone, and if they're not, or they're watching on YouTube, have a great day. And I look forward to seeing most of y'all here next month. Cheers, everybody.